Hello, welcome everyone. On this presentation about the ISC on the calculation of vehicle body, force acting on it as a resistive force using the SCILAB modeling, using the cost modeling simulation. Right now, I would like to welcome with my colleagues Sandeep Kumar Patel from Mechanical Department. My name is Nitish Kumar Gupta. I am from Automobile Department. As a student of Mechatronics, we are presenting this ISC. Uh, from here onward, I like to call my friend Sandeep to move forward from this presentation. Over to you, Sandeep.
Thank you, Nitesh. So our topic is introduction on the vehicle body calculation by modeling. So you are using the SCILAB for our modeling calculation. So our today topic is about the different category we are going to explain today. So WLTC drive cycle, mathematical expression for energy consumption, and vehicle parameter input data, and cost block diagram and output discussion. So we can see the average energy consumption of the vehicle, that is denoted by the E average, will be calculated on the homologation cycle. For example, you are going to use the WLTC drive cycle. So actually, when our vehicle is moving on the road, it consumes some energy. That energy you are going to calculate today by using the SCILAB. So WRTC have different cycle. So class, you can say class. So there are three type of class. The first class is low power vehicle with PW less than 22, and second cycle is vehicle with PW between 22 and 34, and third one is the high power vehicle with PW greater than 34. So PW means the power to weight, which we calculated by using a formula that is known as P max upon PB. So the energy consumption in the is calculated based on the road load. So there are different type of load is acting our vehicle when it is moving on the road. So total road load is the sum of the inertia force, road slope force, and the road load, that is frictional force, and last one is the aerodynamic force. So inertia force means that the mass force, which is denoted by the FIN, and the road slope force, that is in the gradient force, which is denoted by FSN. And third one is the road load force, that is a frictional force, which is denoted by FRN. And last one is the aerodynamic drag force, which is denoted by FAN. So for total resistive force, you are calculated by summation all the forces which are acting on the vehicle body. That is the FIN plus FSN plus FRN and FAN. So if you calculate the total power, so total power is calculated as the product between the total load force and the vehicle speed. So here is a formula you have. So P total is equal to the PF force total into.
Sandeep. Excuse me. I have one question about what is that BV? Can you explain?
Okay. BB means the velocity that you got from previous this graph. That is the speed and time graph. From when you are going to derivative you are going to use on this graph, and that there is different wave is produced on the when our vehicle is moving and with respect to time and with respect to speed. From that where you get the BB, that is velocity.
Okay,
So
okay, thanks.
so next one, if you calculate the total energy, that is the integration of the our P total into PT. So I would like to call my latest friend to explain further.
Uh, Thank you, Sandeep. After that, then the third agenda, there is a vehicle initial vehicle parameter as an input set, and we are going to set this vehicle parameter as an input in the SCILAB only using the set context. The vehicle parameters where you're going to using because every time we're going to iterate if some calculation were done, but we have to change the parameter that is going to iterate again. So we can use as a not a constant value. We can use name that constant value as a variable. Here, like examples like a vehicle mass density coefficient as a resistive force, and drag also, and frontal area of the car, gravity, and that is a final velocity we can get from the drive cycle. Next slide. So this is basically the simulating canvas of the SCILAB as a cost diagram block. You can see in there's a DT, that is a time step we are taken as a 1 second. From the left, you can take the WLT drive cycle. This is as an input, and from there we can convert it into the meter per second using the gain. From there, as a we can take it as an expression for the calculate the resistive force, because we are calculating resistive force because energy spent is required as energy needed, because energy spent must be equal to the energy required to drive the cycle, sorry, to drive the car. So we have calculated total resistive force acting on this. So first one is a road load force, that and it having the expression in the constant block, and second one is about the aerodynamic force, and the last one is a inertia force. Summing up to get the total force, and using the velocity from the drive cycle multiplying with the force, we can get the power, and we're converting into the watt into kilowatt, and we get at the power in a kilowatt. At the downside, you can look that by using the same drive cycle, because in the same drive cycle we have the total resistive force also acting, and plus we can also get the acceleration and deceleration. So back to the dynamic index, where the value is greater than the threshold, you are using as acceleration, and less than the threshold, we are using the deceleration. Doing the integration to get as a displacement, and at least multiplying with the energy, we get the multiplying with the power, we get the energy. From there, we convert it into the joule to the kilowatt, and summing up, and we get the total propelling energy as a to propel, like taking the contrast of the acceleration. And from here onward, we are going to calculate the average energy. Already the Sandeep discussed to calculate the average energy, which is the watt hour per kilometer. And this as a range of in the WLTC, we have taken the lab drive cycle, like taking up the 22 kilometer of the total complete lab, and dividing by it, we can get the average energy. So this is basically overall view of modeling in the SCILAB. Next slide. This is the output discussion also, and one of the input regarding that. Total the drive cycle is about the 1800, and we have taken the sampling of the 1800 itself. So our delta T is a 1. Using as a delta T is a 1, we can calculate the E energy, because already Sandeep told about it is a gradient, it is an integration of the power into the dt. And from here also, we have basically in the, especially in the FESC, we are not taking the gradability, so we have taken the road slope which goes to 0, and the summing up with the attractive force as acceleration, and minusing the braking energy, because braking energy is not going to use as a drag that is acting on the vehicle. So minusing the braking and adding up the acceleration in the tractive, we can calculate the total energy acting on the body. That is energy spent. So we are going to provide the energy as a form of battery in the electric drivetrain. So this is basically overview of vehicle body calculation using the SCILAB.
This?
Yes.
Yeah.
Yes.
Which one is the best while doing the modeling, MATLAB or SCILAB?
The diagram one. Yeah. Basically, you can see in this canvas, there's not too much friendly interactive, like we cannot provide too much data in this. As you can see, the signal blender is provided, but spreadsheet from the spreadsheet not provided, because many data calculated on the Excel. We cannot put directly, we have to build up, and we have to do the integration by providing the dt. There is no limit, we can provide the dt on here, because as integration is about the limit calculation, but we have to provide the dt as a sample time. And basically in the MATLAB, there is a too much subsystem categorization. We can also categorize the subsystem, but there's no powertrain block set. It is already given in the MATLAB. So it is basically easy to calculate rather than this. And what is the issue about this? We have only one the solution right time. So we cannot give our solution or provide the time who are working on it. So basically, I think that MATLAB is far better for the engineer which are working as a professional. This is only for the starting as a beginner, we can learn it. For as a professional things, I'm going to MATLAB is one of the best. I hope I've given you answer.
Thank you.
So from here onward, I like to conclude this presentation. Thank you, everybody.